Thank you very much for coming. My name is Michael Dubinsky. We're going to talk today about zero trust, which is a marketing concept, and it's also a technological model, and I kind of want to separate the marketing buzz from what it actually is and what it isn't. This is what my company, Illuminate, is doing, but I'm not going to pitch the company seriously. I'm not going to sell you on anything. There's a lot of other solutions in the market, so I'll try to mention those, and companies like Microsoft and Azure AD doing similar things. So it's a lot of discussion about the concept, and I'd love to get feedback, and I'd love to keep it as open as possible, because really it's a new concept. I think it's the right thing for everyone to do, and I'd like to keep this as an open discussion as much as possible. Personally, I manage the product at Illuminate. Before Illuminate, I was actually at Microsoft for 3 years, managing the product team for Advanced Threat Analytics and Azure ATP, coming from the Orado acquisition. So that's kind of my background around identity security, identity protection. Before that, I was actually doing a lot of field work on Active Directory as part of Microsoft as well. And our agenda today, first of all, why do we need zero trust? What's happening right now that is changing, and why is it important? The next thing is, yeah, you see the same slide. What are the building blocks of the zero trust architecture? Where can we start? And then I'll show you a really quick demo of Illuminate, how we approach this problem, and hopefully it would make sense. So first of all, in terms of why do we need the zero trust and what's changed? So I think everyone, or almost everyone, are sold on the identity that the network perimeter is gone. And the fact is that in the traditional world, we had this network perimeter where everyone was inside the data center. We had the firewalls, the VPNs, the proxies, controlling the access into the data center, where the goal was to keep the bad guys out of the data center using all of those controls and make sure the good guys can actually go into the data center and consume the resources, the data, whatever the case is. Now, there were a couple of challenges with that fact, that once we provided the network level access, it opened us to different kinds of attacks, like network level attacks, lateral movement, things like that, because eventually when the user and the device was on the network, they had network level access to a lot of resources, usually to everything. Like the segmentation projects inside enterprise data centers mostly failed for complexity, for a lot of reasons. But in general, that model worked, and we tried to mitigate those kind of problems with different tools, like detection tools, protection tools on the endpoints, things like that. Now, what's changed is that in the modern IT environment, the network perimeter is completely gone. So we have SaaS applications, we have cloud-based data centers, we have data everywhere, we have mobile devices, bring your own device, we have remote workforce, we have third-party and contractors, and basically there is no perimeter. We can actually say, well, this is our network, and we want to keep the good guys on the network, and we want to keep the bad guys off the network, because seriously, there is no network. So it's really something we can try and fight it. We can try and still create the perimeter around all of those segments, but it's not going to scale, and it's going to be very, very complex. And obviously, this is a good challenge. Once the defenders have a challenge, the attackers kind of happy about it, and they just go around and brute force SSH and RDP open to the internet on Azure and AWS and everywhere. So attackers are happy about it in general. So what's broken? First of all, one of the goals of the cloud is the agility and how dynamic it is. So DevOps team, IT ops team, they can actually spin up entire data centers in a matter of minutes. Seriously, everything is API driven. You have solutions like Terraform. You can actually go and implement an entire data center in a single configuration script, and that's it. Seriously, it takes minutes. So one of the goals of the cloud is the agility and the speed. And if we'll try to feed the deployment of the traditional appliances and network level configuration, it's going to cost us on that agility. The second thing is that users are working from anywhere, from any device. So again, this is a change less related to the cloud, more related to the modern workplace, that users really want to work from their mobile devices and go through their data and through their emails, or from bring your own device, or maybe we have partners, things like that. And the last thing, which I mentioned, network level access actually is golden for attackers. So again, lateral movement, network level attacks. There is a bunch of examples I can give from my previous role of what was going on and the things we were detecting with Azure ATP and ATA. But really, attackers love the network level access because it gives them the ability to connect to any resource and to any endpoint. So what is Zero Trust? First of all, Zero Trust is an access model. It's not a technology. It's not a solution. It's an access model. It's a concept that is based on a lot of other technological solutions, right? So it's not like you can buy one solution and it would say, well, I have Zero Trust right now. No, it's not. It's actual work you need to do. And the goal is basically to make sure that the access to the data and resources is not performed from compromised accounts, from compromised devices, that eventually the goal is to make sure our data and resources is secure. That's the goal of Zero Trust, that's the concept. And the tagline of Zero Trust is never trust, always verify, right? So we don't trust the network. We don't look at the network as a trust boundary. One of the things that Google mentioned, and they actually implemented something similar internally, they call it Beyond Corp, that's their project name, is that the internal network in Google, so if you go into the Google offices and plug your device into the wall, it's the same to them as if you're connecting from the Starbucks Wi-Fi. It doesn't matter. Like the network inside Google is not trusted. You can go in Google, you can go into Starbucks, you're going to get exactly the same level of access, you're going to get exactly the same access to the same resources, and it's not network-based. So the network is no longer a trust boundary. That's the first important concept of what Zero Trust is. And it's designed, that this model is designed to address lateral movement threats and network level attacks. And again, there are a couple of technological concepts. One is microsegmentation inside the network. So once we have a resource, once we have a server, where that server can go. And the other thing is the granular perimeter enforcement. So when we're talking about users that are accessing resources from whatever devices, how can we enforce the security on those types of access? But in general, the idea of Zero Trust is, first of all, you say no. Nobody can access anywhere. And then you need to make a decision, what level of access, what level of trust do you actually provide? So what are the key principles of Zero Trust? First of all, we need to ensure that all data and resources is accessed based on user and device contexts, right? So again, if we don't trust the network, what do we trust? Well, first of all, nothing. That's the concept of Zero Trust. But we're looking at the user and we're looking at the device, and we're trying to figure out, can we trust that identity and can we trust that device? That's the decision point we need to make inside the Zero Trust concept in order to provide access into a specific resource, into a specific data. Okay, so that's concept number one. The second is least privilege access strategy for everything. So it's not only privileged access, it's not only permissions, it's everything. Again, by default, nobody has access to anything. Now, when a user attempts to access a specific resource, how do we make that decision? Well, there should be policies, there's a bunch of technological concepts about how is it possible, but the user should never have more access than they're entitled to. Third thing, we need to add as much authentication methods as possible to counter credentials-based attacks. So again, this is part of the Zero Trust model, and obviously MFA is a big thing of it. But there is also new authentication method based on the FIDO Alliance and web authentication, Windows Hello, a bunch of stuff. That's a huge part of the Zero Trust model. How do you protect the identity? And I'm going to talk a little bit about that. Never trust, always keep adding context. So what do we mean by that? So one context is who is the user, right? Which roles are they member of? The second context is how did the user authenticate, right? Did they use MFA? Did they use Windows Hello? Did they do something important? A third thing could be the user's risk score, right? How legitimate their operations were in the last couple of hours, days, weeks, whatever the case is. Same thing goes for the device, right? Do we have secure boot on the device? Do we have credential guard? Do we have an EDR that says that maybe the device is compromised and maybe I don't want to allow any kind of access from that specific device because right now it's an ongoing investigation as part of a potential breach, things like that. And the last thing is always verify, which means inspect, log, and look at all the traffic or everything that is happening, because maybe, even though you made a decision to allow a user access to a specific resource, maybe it wasn't the right decision, right? So there is this notion, and kind of going back to my ATA times, there is this notion of an OODA loop, of observe, orient, decide, and act, which you take an action that the user has done, you need to feed it back into some kind of solution that can make sense of that action and say, was that action malicious or benign? Then you're taking that result, feeding that back to the decision engine and saying, well, what about the next action? Should I allow the user that specific request? Should I allow the user access to that specific data? Whatever the case is. So like I'm thinking about that as a loop that we should always take our logs. And again, it doesn't matter what technological solution we're talking about. We should take that logs and we need to pass it through some kind of an analytics engine in order to make the right decision the next time the user is requesting something from that account or from that device or whatever the case is. So that's what I mean by inspect and log all traffic. Does that make sense? Yes. How many of you were familiar with the concept of zero trust before right now? Nice. Okay. So what are the other buzzwords in that realm? So there is software-defined perimeter. What is software-defined perimeter? So software-defined perimeter is an architecture, right? So if zero trust is a model, it's a way to think about the problem. The zero trust, the software-defined perimeter is actually an architecture. There are companies that implement that architecture in specific products. We're doing something very similar to the architecture. There are other companies. And the idea is to allow least privilege access by authorizing the identity and the device. So very similar to the zero trust concept. And the idea, the technical idea behind the software-defined perimeter is that you take the network traffic, you actually take the network packet, that's what those solutions do, and you add a header on top of that network packet that says who is the user and who is the device. Now, the way I think about what software-defined perimeter is, it's a way to take the network level and kind of abstract that into a level that fits the IAM model, the authentication, authorization, and auditing model. Right? So instead of creating a firewall policy that says this is a source IP, source port, destination IP, destination port, allow, block, whatever the case is, we're no longer looking at the IPs and the ports. We don't care what IP it's coming from. We care about the identity and the device that this packet is coming from. So the concept of software-defined perimeter is a concept that helps create products that actually take the network level access and kind of abstract that to an upper level of identity and device. So that's what SDP is. There is a working group in Cloud Security Alliance that actually looks into what's the best way to build that kind of architecture. So this is SDP. Beyond Corp is Google's internal implementation. So it's the project name. If you go and you search for Beyond Corp, there is actually a couple of very interesting PDFs. What Google did, they actually shipped a product inside the Google Cloud Platform that's called Identity Aware Proxy. So it's an HTTP reverse proxy that is identity aware. But the big thing about Beyond Corp is not the product itself. It's not the identity aware proxy, but it's actually the project Google did internally, how to map all the access of all the users from all the devices to all the resources, how they segmented the VLANs, how they started moving users into zero trust VLANs in order to actually implement that project. So looking at Beyond Corp is, again, there's the technological part of it, but the interesting part to me is actually how a company, an enterprise the size of Google, went from fully trusting the network to going, they didn't get to 100%, but let's say almost 95% of really zero trust access to all of their corporate resources. Now, at Google, maybe it was even a little bit easier because the concept at Google, everything, almost all of their internal applications are web applications. So it's much easier when you have an HTTP reverse proxy that is identity aware and you have a bunch of web applications you can access through that proxy. This is not the reality for most of us. We have RDP, we have SSH, we have maybe old FAT client protocols like TCP based. So really it's a hard thing to accomplish. But again, the process and the project and the way Google approached the problem, I think it's a very interesting read in terms of how to approach a problem, that problem at enterprise scale. So this is the Google's Beyond Corp project. So it's a great question for the building blocks of Zero Trust. And one of the building blocks is device security. So SDP or Zero Trust doesn't solve the problem of device security, right? So how do you figure out there is no malware on the endpoint that can inject something into the TCP packet or whatever the case is? Yeah, this is not SDP, right? This is a different solution. This is EDR solutions that you need to have as part of the Zero Trust access model, okay? So the building blocks of Zero Trust. First of all, identity security. Talk about that in a second. Device security. So very similar. We need to trust the identity. We need to trust the device. So we need to figure out how can we secure our identity to make it trustworthy. How can we secure our devices to make them trustworthy, obviously up to a certain level. Then we need to talk about the access fabric itself, right? So if we don't trust the network, how do users technically do the packets sending from point A to point B? And the last thing is the access management in general, but the least privileged access management, how we go about implementing that. So first of all, identity security. Point number one, just go and implement MFA. Seriously, like I'm not selling MFA. There's a lot of solutions in the market. We have Silverfort here, there is Duo, there is Okta, there is Azure AD, there is Google Authenticator, which is for free. There is a bunch of solutions you can go and implement. Seriously, step number one, forget about Zero Trust, go and do MFA. I'm not kidding. Like, you have to trust your identities. You need to make sure that your identities are not being compromised. And this is a pretty good first step. Like, in terms of value for money, I'm a huge believer in MFA. The second thing, and this is something that it's worth keeping an eye on, those are the new authentication methods. So again, this is just coming to market, things like the web authentication, FIDO Alliance-based, Windows Hello. I think there is a lot of work happening in terms of how can we better authenticate, not based on passwords. And it's very interesting. Again, this is not widely adopted yet, but I think we, in general, as an industry, we need to look at those authentication standards, and we need two things. One, help the vendors drive those authentication standards, because obviously everything is working in a lab, and then you go to an enterprise environment and things break. We all know that. So I think it's our responsibility as a community around identity to help the vendors drive those authentication methods. So again, if you could POC those in your environment and kind of give feedback or participate in the working groups, I think it's a great service to our industry. So that's about the authentication methods. The third thing is risk scoring, and I mentioned that, so UEBA solutions. Again, I'm biased. We were building one at Microsoft, or like the solution is still being built. It's always being built. But how can you look into the user's activities, into the user's action, and decide whether those are malicious or benign? And I think it's a very important challenge, because a lot of times attackers, well, we all know they compromise identities, but the other thing is attackers really take this concept of living off the land, right? They no longer bring in their malwares or their tools or things like that. They land on a device, and they have sysinternal tools, and they have built-in Windows tools like WMIC and NetUse and PowerShell remoting and all that kind of stuff, which is really golden for attackers. But it's also very important for us as IT people to use those tools, right? So if you see someone remotely creating a schedule task using sketchtask.exe, or remotely creating a service, or doing PSExec, how do you differentiate between whether that's a malicious behavior or a benign behavior? So that's the type of challenge that UEBA solutions are taking upon themselves to solve. I think that the best approach, or the right approach of UEBA solutions, is actually risk scoring, because really, like, you don't have, or it's rarely the case you have 100% confidence that something is really malicious, right? So I'm a big believer in risk scoring, and it shouldn't be like risk score 400, right? What's 400? Is it good? Is it bad? I don't know. But looking at like low, medium, high, critical, things like that, something that is actionable, I think it's super important for looking at compromised identities and looking as part of the identity security ecosystem, what's the status of our identities. So that's the third thing. And then the last thing is just get the basics right. Roles management, identity governance. When someone leaves a company, make sure their user account is disabled or it doesn't have any access. Make sure you have integration with HR systems that when a user is coming in, you know exactly which roles they own. When they move to different positions in the company, make sure the roles are up to date. So those are basically the basics of role management and identity governance. And I think it's super, super, super important to get those basics right as well. So that's about identity security. There is obviously a lot of things to say. I think the entire conference is about identity security and identity protection. But that's kind of my thoughts about the identity security part. Okay. So basically, all of that goes into user context, right? So who is the user? It's not only the question of the username and the password, but it's really a question of all of the above. How did they authenticate? What's their risk score? Obviously, what roles are they member of? And what's their status in the company? Things like that. So that's the context of who the user is. Next part, our device security. So very similar. In terms of the device protection, so again, there's a lot of features that are being built into Windows. And actually, I'm using a Mac right now, and Apple is kind of behind on that, have to be honest. But things like Secure Boot, Device Guard, all the features that help you protect the device from malicious code and even hardware-level attacks. So that's number one. Number two is similar to what we have risk scoring for users. We have risk scoring for devices. That's if UEBA is doing that for mostly for user actions. So EDR solution mostly doing that for devices. So they're looking at which processes are accessing which memory segments. Is that a legitimate access or not? And again, I'm talking about the novel EDR solutions. Usually those are the cloud-based and like Carbon Black and Sentinel-1 and Silo and Windows Defender ATP. Those are the guys that really take behavior into account. And again, these are not users' actions. Those are process actions that are being evaluated. Okay, so those are the EDR solutions. And again, the last thing, very similar to identity governance, that's the user device inventory, right? So do we have a new device inside our corporate, not inside, but that was purchased by our company? Do we have a new device that was enrolled? Is that a legitimate device? So how do we manage the device inventory? Very similar to identity governance. How do we manage the users that are coming into work for the company and are leaving the company or moving to different positions? And this is the device context. So again, so we have a lot of things happening on the user. We have a lot of things happening on the device. We want to take the context of both of those areas and then try and make an access decision based on that. So those are two types of context we have. Now, the third thing, sometimes, and again, not always, but we need an access fabric. Why do we need an access fabric? So if we're talking about SaaS solutions, this is less required because the access fabric is actually being taken care of by the SaaS vendor. When you go into Office 365, when you go into Salesforce, they make sure the access is secure. They do the certificates, they do the authentication, they do a lot of stuff to make sure the access itself is secure. But when we're talking about data center access, and again, maybe it's on-prem, maybe it's cloud-based data center, doesn't matter what the case is, we need someone, we can think about VPN, but VPN is the access fabric of network level access. We need to think about the access fabric that supports the identity and device context for the access decision. And again, my recommendation, one, preferably cloud native, so it could scale. So again, we're talking about going back to the agility and the speed of the cloud. So now you have one data center with 5 VMs. Tomorrow you have 20 data centers with 5,000 VMs. If you need to deploy 20 VPN appliances to support that, it's going to take you a while, right? So this is the reason I'm recommending cloud native, something that can scale up, can scale down, would be much easier to implement. And again, cloud agnostic, because from right now at Luminate, we work with a lot of customers. And one of the interesting things I heard from customers, it's actually a huge gaming company. So the CISO there, he said, well, we're cloud agnostic. I go like, how do you do cloud agnostic? You have like PaaS services on each cloud. You have things that you need to run on per cloud basis. So I'm like, yes, we actually have an engineering team that abstracts that away because we want to run games in Google Cloud in Asia because the cost there, the latency there is lower, and in Azure in Europe because the cost is lower, and in AWS in the US because whatever the case is. So really what they care about, they don't care about the cloud vendor. They abstract that away, and they really want to make what makes the most sense for their business, whether that's latency or cost. In their example, that was latency and cost. They're doing a lot of video rendering and video sending and CDNs and stuff like that. So obviously, there are differences between different cloud vendors in different regions. So that's the reason for the cloud agnostic stuff. And the last thing is the access management itself. So how do we go about least privilege access management? So again, a couple of the concepts. Manage access, to provide access only to required resources. This is actually hard to do because if we want to do that in our traditional on-prem enterprise, we need to map who has access to any resource. Good luck with that. It's doable, but yeah, it's hard. We need to audit everything. And two concepts, and again, that's like my personal concepts when I think about the notion of zero trust. First of all, the access decision is not a true-false, right? So it used to be true-false. Can the user access resource X? Yes, no. I think about the access decision as maybe it's false, so maybe we should completely block the access. If we don't, what can the user do given the context? So a good example of products that implement that notion is CASBs, Cloud App Security Brokers, right? They can look at the context, or some of them maybe can look at the context and go like, well, given the context, the user cannot access PII data on Salesforce, or given the context, the user cannot download files from Box, or again, whatever example you can think about. So it's no longer like a true-false. The user can access Salesforce, or the user can't access Salesforce, but either it's false, the user can't access Salesforce, or what can the user do in Salesforce? So I think we need to think about access management, again, not as a true-false, but more granularly. False, or given the context, what's true, okay? And the last thing, again, just-in-time and just-enough access. So just-enough access really relates to what should be true. It's the same concept. So really, I'm borrowing concepts from privileged identity management and privileged access management into general access management, right? Because in privileged access management, we had this just enough administration, and there was a discussion about partial just enough administration, and it's not the only solution that does that. But we never thought it's just enough access for the regular users. It was only in the realm of the admin accounts. And I think we need to take that idea of just enough access and use that for everyone. Again, given the context, just enough access. And just-in-time access, again, really ties into privileged access management. But mostly, again, what we hear from customer is that maybe you have a ticket open in Jira, and then the developer needs to access part of the development environment, or maybe you have things in ServiceNow that you want to integrate and things like that. So that's kind of the just-in-time access concepts that really needs to be integrated more into the company workflows. That's about the least privilege access management. Okay. So where do we start? By the way, how much time do I have?
15 minutes.
15 minutes, okay. So where do we start? Again, in order, identity protection, device protection, not necessarily in that order, but both of those are critical in order to go to the zero trust concept. IAM and identity governance, again, we talked about it. We need to be able to collect the context out of all of those. So again, we need solutions that actually help us collect the context from the user, again, how they authenticated, what groups they are in, what's the risk score, things like that. And then in terms of going zero trust, there are two approaches that you could go. One is destination-based, and one is audience-based. So I just want to talk a couple of minutes about those approaches. What's destination-based? It's based on the resource. And the way kind of we see it is, again, leveraging cloud adoption, because making a sense of the mess we have in the on-prem world would be very, very hard. But at least, start fresh, start right kind of concept. So you're going to the cloud, again, you're adopting SaaS, you're adopting cloud-based data centers. Think about the zero trust access model when going there, right? And again, I'm not talking about specific technological solutions. We talked about CASBs, we talked about EDRs, we talked about UEBA solutions. Again, not any vendor in particular, but look into how you can implement that for your cloud applications. Again, SaaS and cloud-based data centers. That's target-based option number one. target-based option number 2 is the crown jewels. So maybe you have, like a customer-facing production environment, again, regardless of where it's running. Maybe it's in the on-prem, maybe it's in the cloud. Or maybe you have like very sensitive resources that host very sensitive data. So that's the other destination-based approach. Less common from what we see. Mostly we see customers kind of thinking about that when they're adopting the cloud, less thinking about their crown jewels because really it's tougher to do, but it's also a possibility. So that's the destination-based approach. The audience-based approach is based on groups of people. So map the audience and their requirements, and maybe it actually makes sense to do that for a specific audience. So again, very common example is DevOps, CloudOps, ITOps, whatever you want to call them, the people that actually manage the cloud-based environment. So again, it kind of ties into privileged access management, but it's much more than that. But that's a very common audience. You can go and start implementing for that specific audience, and you can work with that audience to map their needs and create the solutions and the policies based on that. Another option is remote workforce. So again, they're traveling. They need to have access from remote locations into the corporate data center, so you can map that as well. It's actually much easier. You could take the VPN logs and kind of figure out where people are accessing and try and get those resources eventually there. Third-party partners, contractors, and that also really ties into bring your own device, because you have devices that you don't want on your network, right? Whether those are personal devices or BYODs, or maybe it's a partner or a contractor where, well, obviously you could take a laptop, build it with your corporate image, and send it to them. Doesn't really scale. And having their devices on your corporate network is generally a bad idea because you really don't know what's the security of their device. So again, going back to the zero trust, you definitely, you don't want to trust your own devices. You definitely don't want to trust your contractors or third-party vendors' devices. And there is enough examples of breaches happening by third-party vendors. So I'm not gonna list those, but there are a couple of very famous ones. So those are the types of access scenarios. And just deploy the connector. And here we go. And that's it. In a second, we'll see that the site is online. And that means the connector is actually, here we go, that the connector has actually reached out to our cloud service. So in terms of incoming network traffic, any drop, like simplest firewall rule, nothing is coming in, which is a good thing. But then we need to provide access to the application somehow. So the next thing I'm doing, I'm creating a new application. So right now we support 3 types of applications. Obviously there are more applications that are coming. So we natively support web, SSH, and RDP. So we can do the web example. So in this example I have Confluence Wiki, which is hosted on a VM. I'm providing the internal IP address inside that network segment. I'm selecting the site. And the next thing I'm doing, I'm actually selecting the identities and in the very near future the devices or the condition of the device which can access this application. So again, in this example, I'm integrated with Okta. So I can choose groups or users from Okta, or could be AD, could be anything. Obviously, let me select myself as well. Single sign-on stuff, custom domains, a lot of things on top of that. And we're saving the application. So the idea here is that instead of deploying firewalls and then VPNs or proxies or virtual appliances, this is the amount of time it took me to provide secure access to a web application hosted in a cloud. I'm just going to launch that application, and we'll see my Okta authentication. And here we go. We're inside the app. I'm signed in to the application itself using single sign-on. Again, that's the amount of time it took me, minus the integration with Okta, which takes a couple of more minutes. So that's one example. Another example, let's do an RDP application. So this Confluence is hosted on a Windows VM. So same thing, selecting the site, selecting the users from whatever identity provider I have, saving that. So we're validating we actually have access, and the connector can actually go into the RDP or the web or the SSH application. And in a second, we'll have this application published. So for RDP, I'm going to go to our application portal. And what we have here, we have our Okta username. We have the temporary token, which I need to go into the portal and authenticate with my Okta and MFA and everything in order to get those credentials. So again, currently there is nothing exposed to the internet. And I'm just using my native RDP client in order to authenticate to Luminate using the temporary access token. And now I'm already being prompted for my credentials to the remote device. So technically, it's a multi-tenant RDP gateway. You can think about it as that's the application level proxy for RDP. It's an RDP gateway. So I'm providing my credentials. The regular certificate message. Everyone gets that all the time. And that's it. So now I'm natively RDP'd into my Windows box. So that's it in terms of the demo. Obviously, there's a bunch of other things I can show, like governance policies, which we have here, or activity logs. So again, everything is audited at the application layer. So my access to the wiki, all the information, which URL, location, device, everything is here. Obviously, it can be exported to your UEBA, SIEM, whatever the case is, solution, and used for risk scoring. Yeah?
Regarding the demo, could you provide single sign-on to the user experience so that the user doesn't need to type in password? Or
For RDP?
yeah.
We're working on that. Yes. The answer is yes, not right now, but we're working on it.
Okay.
So for device context, and is that a problem you guys have solved, or do you think about that? How do you think about that?
So we're kind of offloading that problem to other. We want to integrate with the solutions that solve that problem. We don't want to solve that problem ourselves. But what we see from a lot of our customers, they actually take pre-breach solution like health check solutions, and they use that for device inventory as well. So basically, any device that doesn't have their pre-breach solution deployed, it's not part of the corporate image or the inventory, right? So maybe it could be like technical issue. Obviously, there are support cases, blah, 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 but that's the approach we mostly see. Okay. So back here. So to finish up, the conclusions, things I'd like you to take away from that talk. First of all, explore the zero trust model. I don't say implement that tomorrow, but just explore it, think about it, because it takes time and it takes a state of mind to actually go and implement zero trust. The second thing, again, when you go to the cloud, that's a great opportunity to evaluate your access strategy. So again, thinking about SaaS, think about how does your SSO or cloud-based identity solution can help you with providing or managing the access to that. Think about CASB solutions that can actually help you with the granular access, like is it false or what can the user do inside the application. So that's a great point to evaluate those kind of solutions. Again, going to the cloud. Same thing goes for cloud-based data centers. Identity protection infrastructure. So I think enough has been said in the conference. I don't need to convince you on that. Identity and device context collection. So even though the industry is not there right now in being able to seamlessly integrate across solutions and being able to take risk scores from any UEBA solution into any authorization decision solution, I think we're going there. So the earlier you begin to collect context, and again, pushing the vendors into actually helping you take that context to the access decision, and again, it could be Microsoft, it could be Okta, it could be us, it could be trying to make this really as vendor agnostic as possible, because everyone has a lot of work to do into taking every single piece of context to make an authorization decision. But I think we have to go there. So if you're looking into those kinds of solutions, that's great. And think about solutions that can provide context in the future for those authorization decisions. And then the last thing, and that's the hardest one, think about solutions that can help you with context-based access enforcement. I think that should be a very big decision point in terms of what solution do you buy in terms of authorization management or access management or whatever it's called. So looking into access management solutions that don't even have the basics and don't even have something like that on the near-term roadmap, I think it would be a mistake. and again, I'm not trying to shut any kind of access management solution down or alleviate any other access management, but those are my personal thoughts, and I think Zero Trust, we're at the point where we're sharing personal thoughts. There is no like one solution saying, hey, this is Zero Trust, this is the blueprint of Zero Trust. No, we're all working towards that. But I really think we need to make context-based access enforcement a really cornerstone part of our access management methodology. That's it. I'm done. More than happy to answer questions. My email. That's it. Thank you.